Welcome to EDU World Space.
In this problem, we have a model for a leg where we have um, the lower leg is being extended and the person is just holding their leg up. This is supported here somehow. And then we have the tendon here that attaches to the quadricep here, and it makes an angle of phi with the axis of the leg, of the lower leg. So we're going to use the axis here as x along the lower leg and then y perpendicular. So we have the weight of the foot, the weight of the leg, the reaction force where the at the knee joint, and then the tendon force holding the leg, keeping the leg from rotating. And we're told that this is 25 degrees. These forces are in the negative direction, so that's their y components are negative. So we have the weight of the leg is 30 newtons and the weight of the foot is 12.5 newtons. And then the angle that the leg is raised above the vertical is 40 degrees. So if we we have these forces we can write as vectors if we want. So we have all their components, and then we can again T, and these are the forces along this x. I is in this way and J is in this way, and so T is just the projection onto here and here. And so then we just need to, the moment arms are all in the purely in the x direction. So here we have, the moments are r cross f, all these r cross all the f's. And so um, the distance from the pivot, so we take moments about the pivot, the distance from the pivot to the to where t is applied is L over 5 in the I direction. And that gives us t L over 5 times sine of phi for the moment caused by that. And then FL, it acts at L over 2. And we can see then that FL of y here is the moment caused by this is FLY, L over 2 times sine of theta. And for this moment, it acts at the end, so L in the x direction. And so the moment we get from that is this right here. And now we have everything, actually we know everything in this equation here, except for t. So we can solve for t and we find that it is 209 newtons. So obviously a lot more than the weight of these because obviously the moment arm is short, and also the perpendicular component of this tendon force is also is not very large because of the shallow angle here. Then we can use force balances if we wanted to figure out what this reaction force at the knee joint was, but we weren't asked to do that.